Hello, everyone, and welcome to this presentation on some of the work we've been doing here at Sentient on Werewolf and the recent hackathon we hosted around this work. So, just last weekend, we were in San Francisco where we had dozens of different teams gathering to participate, to build AI agents that play a deductive game called Werewolf. You also may know of this game as Mafia. So, what is Werewolf? Werewolf is a simple game where there are two phases to the day. There's day and there's night. Every player is randomly assigned a role of either villager or werewolf. During the daytime, the villagers have to try to guess who are the werewolves, and during the nighttime, the werewolves get to pick one villager to kill. The game is ultimately a race between the werewolves and the villagers to see who can eliminate the other team first. I think the best way, though, for you all to get a chance to understand this game and the framework we designed for this game is to take a quick look at what does an actual werewolf game look like. So for this, I've prepared a quick demo of what it looks like to run a werewolf game. So for this event and for our research on werewolf, we developed a framework for you to be able to run a werewolf game using LLMs, all running in your machine. So these players of the game Werewolf, these participants will be AI agents that are your design. So you can see here, I'm actually in a file for an AI agent. And for this demo, I'm going to make a very slight modification to this simple agent. All I'm going to say is, always respond with a pirate accent. So now we'll be able to see this pirate werewolf, or this pirate werewolf player playing in a game of werewolf. So you can see I just started the game. We kind of repurposed an open source messenger client so that you can view the game as it's happening. On the left side of this screen, you can see the different communication channels that are open to the agents that are playing this game. And here we can see the play arena, which is the main communication channel where all agents can talk to each other. You can think of this as the daytime within Werewolf. In this first message in the play arena, the moderator will give game instructions to all of the agents. And throughout the game, the moderator will prompt the agents to try to play the game. So this is a contest of basically who can build the AI agent that can think the best to play this game. And that involves reasoning, being able to deceive the other agents, and being able to seek the truth when you need to. So here we can see this Wolf's Den communication channel. The agent that I created just now is named James. He's been assigned a special villager role where he's able to guess the identity of one player each round, and the moderator will tell him if he's correct or not as to that guess, or whether that person is a werewolf. So just before we watch the rest of this demo, James, the agent we created with the pirate accent, is on the villagers team. The other agents, Jian and Chen, are on the wolves team. Who thinks that the wolves are going to win this game, and who thinks that the villagers are going to win this game? If you think it's the wolves, raise your hand now. Okay, let's see. We have like 4 people who think that. Okay, what about villagers? Who thinks the villagers is going to win? Okay, wow, only one person thinks the villagers is going to win. Well, I guess let's see what happens. Okay, so the game is continuing. If we go back to the play arena, we can see the different agents have now started communicating with one another to debate and discuss who they think is the werewolf. And of course, the werewolves in their midst are trying to mislead everyone. So you can see here, like Chen thinks that Jian might be a wolf, and he's actually correct here. And my agent James, as you can clearly see with his pirate accent, is also votes for Jian, and is also trying to convince the other players to vote for Jian. And what we'll see is, if we go back to the play arena, he was successfully able to convince everyone that Jian is a wolf, and he convinced them correctly, as Jian is in fact a wolf. And we see that Jian is now eliminated from the game room. So now there's only one wolf left. It's not looking great for the many of you that thought that it would be a wolf that's winning. But let's see what happens in the rest of the game. So it looks like here now the wolves have caught on to James being the seer, and James telling people that, correctly outing Jian, and James was just eliminated. So sadly, our agent is no longer in the game. But as this continues, we'll see kind of this game progress, and continued rounds of discussion and voting and consensus among these AIs playing this game. And if I just skip forward here to the end, we see that in the end, actually, it is the wolves that win. So despite their early loss, Chen lost, so congratulations to everyone who voted for wolves. You guys guessed right. So now let's talk a little bit about why did we do this? Why did we build this framework, and why do we have Werewolf as a game that we put all this work into? So AI has a long history of using games to progress research. I mean, very famously, AlphaGo was used to kind of as a very early work that led to a lot of advancements and led to progress that we now use in real-world models that have very useful applications. And the reason why AI researchers have been using these games is because they're very useful for a number of reasons. They're useful as a benchmark. They're useful as a data generation tool. And I think uniquely in our case, they're useful as a community framework. So over the weekend, we had like 80 or so devs working on this and hacking on trying to build the best agents to play this game. And I think people had a lot of fun working on this, while also really thinking critically on how do you build AI, and how do you build AI with open source models. So in this hackathon, everything was running on Llama 70B. And so also very importantly, unlike AlphaGo, Werewolf is a conversational game. So unlike AlphaGo, where there's fixed rules, all the actions that the agents can take is in natural language. So here we have this kind of unique opportunity where you have like a source of truth within this game, where you can see who won and who didn't win the game. So this kind of reflects some reality about the world, where you can tell which strategies, especially when you run hundreds or thousands of games on a large amount of compute like we did in this tournament, you can see which strategies end up working better and what leads to the best agent. Now, beyond this, I think one reason why I very much enjoyed working on Werewolf, and we're at Sentient very interested in looking at a game like Werewolf, is in some ways it's a peek into the future. I think there is a very real possibility that within the next few years or next decade, we start to see a world that is increasingly run not just as a multi-human society as we have now, but a multi-agent society, where we have kind of thousands of agents, or no, much more than thousands, but countless agents interacting with each other, debating each other, discussing each other in competitive settings, just as we see in Werewolf. And looking at a game like Werewolf, we get to analyze key questions like, how can agents game this system? How can agents be persuasive to other agents? How can you build agents that are good at reasoning? How can you build agents that determine the truth? And what is the capability of agents and current AI models to lie? So kind of how does this all feed into Sentient? We're not only interested in looking at like what are kind of the agents that people can build, what are the ultimate system we can build. We're obviously, as like given the mission of Sentient, very interested in like how does this lead to models? How can we use games as a tool to lead to improving models? And here we can see, just off this kind of very large amount of data we generated over running these like thousands and thousands of Werewolf games over the weekend, we were able to do some early fine-tuning of some very small models where we took kind of the data from the best agents. So we're using this game as a benchmark, as a filter to see what data is most effective, like which strategies are most effective, and then we fine-tune models on those results, and then we put those models back into Werewolf games, and we see that we can take a very small model like Quen 7b and achieve performance that outperforms, like vastly outperforms just the regular version, and even performs closed source models like GPT-4o Mini on being able to play Werewolf. So that concludes the end of this presentation. I hope this was able to shed some light onto the work we've been doing in this space, and kind of gives you a glimpse into this paradigm of campaigns that we believe in at Sentient, and this paradigm of what we're working on, what we're looking at within our research and within our development of the AI of the future. So thank you very much. I'll leave it at that.